Hi, my name is Noel Davis with World Composting, and today I want to show you a new thing that I built just recently from directions that I found on Thingiverse on a 3D printer. And this is a shredder. This is a 3D printed shredder. The person that made it, he has a company name called Filamaker. He also has a website. I will link it down below along with the direct link to the files to build this. So this is a shredder that he designed. He put it up there for free, and I downloaded it and trying it out. I'm not selling these or anything like that. That is against his terms of service for using his design. I'm here just testing it out after I built it. And you know, it's got a solid piece right here. The sides are all 3D printed. Obviously the screws are actually not, and these bolts, but almost everything else in here is 3D printed. This is what the bottom looks like. Now there is, and you'll see in the parts list here, there is a couple things that are not. In this piece right here, there are some bearings. He has a video on how to put this together that I followed. But there are some bearings in here that I purchased. There's a metal rod or tubing that's square tubing running through this side and this side over here. So those obviously I purchased and did not create from a 3D printer. So this is printed with PLA Plus. So it's supposed to be a little bit stronger than PLA. We'll see how it holds up in the test. This is not going to be one of those tests. I'm going to record all my testing with this, but the way I have it set up here or structured, let me zoom back out here, is I have my workbench here. Let's just move this over a little bit so you can see a little better. I have my workbench. I've got these little catches on here, so I'm going to put, for a setup here, I'm going to have one in front and one on the back side. I'm going to tighten it up here. You probably can't see the knobs to do this, but I am tightening it up. Or at least if I can. I got to move this out of the way a little bit, tighten it up. There we go. Let me tighten up the other side. Make sure it's nice and tight so it doesn't slide around. So now it's in here. It's not going to move around. Hopefully these gears can still move. The bottom is open. Underneath here, by the way, is a bucket, so I can catch food scraps as I put them through here. And then what I'm doing, or what I plan to do here, is have my drill attached. This is a 24mm bit here. So I'm going to have that on here. And the idea is I'm going to spin it really slowly and put food in here and see how it can chop this stuff up. So that is my plan. I'm going to run a series of videos on this as I use it, with close-ups of what's going on and hopefully have some pictures of maybe what's falling into the bucket below. But I wanted to show you what the project was that I was working on here, that I've been working on for all this. As I said, this is all 3D printed. This is a hopper on top. By the way, these are very dangerous if you build one. Actually, before I stick my hands in here, I'm going to unattach that right there. These things, if you put your hand in here, you're going to lose your fingers. This thing will break your hand apart. So you got to be really careful with these things, which is why I did build this hopper. This was actually a add-on that somebody else had put together, and this bolts right in down here to the frame. And overall, I want to say that this cost a little bit more than expected. The piping, I couldn't find the exact size, so I had to buy a big long 4-foot bar and cut it. So that was 17 bucks. The bearings were $20, and the various nuts and bolts were probably another 10 bucks. So maybe 50 bucks total that I spent, not including this PLA right here, which isn't too expensive. Depending on who you go to, it can go as low as maybe 20 bucks to up around $100 per roll to make all this, depending on who you're buying from. I'm not sure exactly how much it all weighs, and I did have some scraps that did not work out very well. Actually, let me bring those over and show you what those scraps look like. All right, so this is one of the, let me see if I can zoom out here just a little bit. No, I can't. So this is actually one of the pieces right here. This is supposed to be this hopper piece. At some point it got off balance and frayed and didn't print very well. So that had to go be disposed of, because obviously this isn't going to work to help sort things into here. The other part that also had printed incorrectly was one of the discs. By the way, this is the infill that I have on these discs. These are, I think, 50% infill, and it was printing up in layers flat on the bed this way and printing upward. But this one somehow became misaligned. I think the filament got caught and it under extruded one level, and then it never caught back up and reattached it properly. So unfortunately that was another piece of scrap. So speaking about extrusion and how these were laid down, everything here almost is built up this way. So this is the low end, this is the high end, and it's just slowly layered on going this way. So all the seams run this way in these center sections here. This piece, these end pieces, which you can see also down here, this end piece right here, that was actually built up, whereas this was the bottom and it built up to these tines. So it's actually built away going upward. So hopefully that'll be able to hold up. I'm a little bit worried about these holding up because of the fact that this is really something where you essentially have layers of plastic on these ends, and I wonder if they will chip away. The gears on the side, let me see if I can show this to you. Let me undo this a little bit here so I can show you these gears. I'm tightening it, that's not going to help. So the gears on the side here, these again, these were printed flat going upward. And then these are little rings that hold it in. This was printed that way as well. These have gears inside that look similar to this, and those are printed upright as well, like coming off. So the square was on the bottom, and it came up into the round section that goes through the bearing that's in here, and it was printed upright. This one, though, which you could tell a little bit right here, I think it's a little bit frayed, was printed on its side. And that was to help with strength, because it's going to be taking this bit right here. And, you know, this is a major amount of torque it's going to be taking on this piece right here. In fact, I heard that this piece is the one that typically breaks. We're going to see how much pressure it can take. We're going to slowly build up. We're going to start maybe with some banana peels and stuff that's kind of soft. And we'll build up to eventually corn cobs. And maybe even, I remember him showing, I think that this could take chicken bones and take up to 74 Newton meters of force. So we'll see how it goes. As I said, I'm going to link below to the Thingiverse files for this. This is this person's design. I'll link to their website as well. They do sell metal ones, which I'm sure are a lot tougher than this 3D printed model is, but they're a little bit kind of expensive for my tastes. So I thought I would try this since, you know, I already had the 3D printer, and we'll see how this goes. So speaking of 3D printers, let me show you what printer I have. All right, here's my printer. I'm hand holding this. Let me turn this on. This is an Ender 3 Pro. I got this at Micro Center. I don't have a good lighting over here, so I'm sorry about that. I don't know if you can read that here, but that shows you the Ender 3 Pro and the software. Let me just bring you up here. I know it's messy behind here, but this is the filament that I use. This is PLA Plus. I don't think it says the brand on here, but this is what I used, and I used all PLA Plus on here. So this right here is the extrusion area right here. This is the bed it prints on, and I was printing things up off the bed. So this bed slides around like this, and this printing area moves up slowly. So that's the way this works, and it ratchet goes back and forth too. This can go back and forth to print. For those of you that have never seen a 3D printer, this is the first one I've ever had. I actually bought it for my kids. My son put it together, so if you're looking for a project for your kids, this might be the way to go. And I'm trying to get him to learn some different things on here. He's actually printed up a couple things too, like this little Yoda here on top that's for the filament. That's what you use to turn the filament in. It goes through this Bowden tube, it's called, down here into the heating block, which is actually down below in this lower section. And let's just see here if I can look up here. Right there, it's hard to see, I know, because of all the stuff behind it and the lighting, but that right there is the nozzle that it prints out of. So that's what I used to print this entire thing. I want to say I probably used 1 kilogram of filament doing it, but, you know, it's not too bad considering, you know, it would have been a few $100 to buy one of these compared to maybe $100 to print it up, and it was probably less than that. It's probably closer to 50 or 70. So with that, let's go back to the shredder so I can kind of give you the dimensions and let you see what it looks like. All right, we're back at the shredder here, and what I wanted to give you is kind of the dimensions of this. So the opening of this, it's not really wide. It's about 6 1/4 inches, and let's just see this way, just under 7 inches. So it's not a real wide unit, but it should be fine for a lot of the shredding that we're doing. By the way, for depth here before you hit the blades is just over 5 inches, which is good here. So I have some space so I can kind of put something in, and if it pops around or moves around a little bit, I don't have to worry too much about it falling out and trying to put it back in or putting my fingers down in here when it's going. That is a big worry that I have. These things, remember, I'm going to reiterate this before every video I have of this. This thing is dangerous. I mean, this thing can crush bone. So we'll see how well this works. We'll see how this holds up. And we'll see what parts break on it, because that's what I'm really curious about, is how well this is going to hold up to being used. I mean, I can already tell that this is starting to flex, but this is hollow. These are 50% infill, I think, for these parts, and this is the only, this knob over here I told you is the only 100% one. So we'll see how well it holds up and how well this does. If you have anything that you want to request that I try in here, let me know in the comments, and that way I can maybe try some things that you're really curious or curious about. If you decide to build one of these, let me know, and let me know what parts you use and everything, and which if you follow the design exactly or not. I didn't really make any changes, although I think looking back I probably would. It was really hard to get all of these on. The 1 1/4 inch piping that I have, the tube that I had, it was really difficult. I actually had to use a chisel to hollow out the pieces a little bit. So let me know what you think in the comments, and I'm going to start recording some videos on this, probably of just zoomed up of it shredding stuff, and I'll go over what it's shredding, okay? So thank you for watching, and please like my videos and give a thumbs up.